Hello everyone, welcome back to my channel. This is Saman Shelvi, Assistant Professor in the Department of Computer Science and Design at SNS College of Engineering. In this video, we are going to see about normalization from the subject Modern Database Management System. Let's start. First of all, what is the purpose of using normalization in DBMS? We must know the need of normalization in DBMS. Normalization is needed to reduce the data redundancy and avoid the data inconsistency. That prevent the update, insert and delete anomalies. So normalization makes the database efficient and reliable one. If normalization is not done in our database, some data will be repeated and data inconsistent may occur and update, delete and insert problems will arise. So we have to maintain normalization when we are using DBMS concept. Consider this example. In this example, we have a unnormalized table with the attributes book ID, title, author, member ID and borrow date. If every time a member borrows a book, the same member detail and book details are repeated. To avoid this, we have to normalize the table because unnormalization causes the data redundancy and wastage of storage space and maintain difficulty in updating the data. So we have to normalize the unnormalized table into with the ID of borrowed. Borrowed with the composite attribute book ID and member ID. The table books with the attributes book ID and title and author. And the member table consists of the attributes like member ID, member name and contact. We are creating the relationship between the books and member using the table borrowed with the attributes borrowed ID, book ID and member ID. This reduces the wastage of storage space and improves the performance. So normalization is the process of organizing the data in our database to reduce the duplicate data and avoid the data problems. If you're implementing normalization in DBMS, we can easily get the better data organization and we can easily update the information. There is no repeated data and we have so much of memory space. So totally all the data in the database is well managed. So types of normalization. In database design, there are different normal forms based on the primary key of your table. These include 1NF, 2NF, 3NF, BCNF, 4NF and 5NF. If the unnormalized form, if we remove the repeating groups, we can get the first normal form. If we remove the partial dependency, we get the two normal form. And if we remove the transitive dependency, we will get 3NF. If we make sure every determinant is a candidate key in the table, we will get the BCNF, that is Boyce chord normal form. If we remove the multi-value dependency, we will get the fourth normal form. And finally, if we remove the joint dependency in our table, we will get the fifth normal form. Let's now discuss these normal forms to understand normalization in DBMS with examples one by one. As I told you earlier, first normal form that ensures each column contains only one atomic values, and second normal form eliminates partial dependency, and third normal form eliminates transitive dependency, and Boyce normal form, that is the stricter version of 3NF that address additional anomalies. And the fourth normal form deals with the multi-value dependency, and fifth normal form that address the joint dependency. Let's see with examples one by one. First one, first normal form. As I said earlier, the rule of 1NF is each column should have only one atomic values. For example, a table fruit record contains information about the fruits acquired from different states to store in the warehouse. In the given table, the states column in the table is multi-valued attributes. Hence, this relation is not in 1NF. To convert this table into 1NF, we have to separate rows for each mango producing state, and the following table will be mango with Uttar Pradesh, mango from Andhra Pradesh and mango from Karnataka. So we are separating into 3 rows. Next one, second normal form. The rule of second normal form is the table must be in 1NF, that is first normal form, and there is no partial dependencies should exist. Consider this example. In the table, the prime attribute are customer ID and plan ID, because on the customer ID that determines the customer name, and the plan ID that determines the plan name. So there is a partial dependency in the table. So we have to eliminate the partial dependency. Consider this example. We have to remove the dependency and convert this table into second normal form. We can divide this table into smaller tables, like using the customer info, plan detail, and to make the relationship between the customer info and plan detail, we are creating the table name customer plan. Customer info table contain the attributes customer ID and customer name, and plan detail table that consists the attributes of plan ID and plan name. To make the relationship between the customer info and plan detail, we are creating the table name customer plan, which makes the relationship between the customer and the plan with attributes customer ID and plan ID. Now the table is in second normal form without any partial dependency. Next one is third normal form. The rule of 3NF is the table must be in 2NF, and there is no transitive dependency should exist in the table. Consider this example. In this table, there is a transitive dependency because of two conditions. That is, the warehouse code that determines the warehouse pin code, and the warehouse name that determines the warehouse city. So we have to eliminate the transitive dependency. That means a non-primary key column that depends on another non-primary key column. We have to eliminate that. So we are dividing the table into two parts. The first one is warehouse detail table with the attributes of warehouse code, warehouse name, and warehouse pin code. And the second table is warehouse location with attributes of warehouse pin code and warehouse city. Warehouse pin code is not a super key, and warehouse city is not a prime attribute. To convert into the third normal form, we will divide the table into two. The table names are warehouse detail and the warehouse location. Now the table is in 3NF. Next one is Boyce code normal form. BCNF is stronger version of 3NF, and the rule of BCNF is every determinant should be a candidate key. It gives better data integrity. Consider this table example. In this table, the project ID is a prime attribute, but the project leader is a non-prime attribute. So we have to divide the table into two to convert into the Boyce code normal form. So here the above table is converted into two table. The table names are student project with attributes of student code and project ID, and the second table name is project lead with attributes of project leader and project ID. In simple, the above table that violates the rules of the BCNF, as the project ID is the primary attribute, but the project leader is a non-prime attribute. So we divide the table into two to convert into the Boyce code normal form. So normalization helps in designing a good database. It reduces the redundancy and improves the consistency. Here I add the mind mapping diagram for normalization in DBMS. So just go through the mind map. So pause the video and try to attend the assessment questions. Why the normalization is needed, and list the normal forms you know, for example 1NF, 2NF, and 3NF, and state the rule of 1NF, and then provide the real examples for 1NF and 2NF. What are the problems will occur if normalization is not done? And the next question is, what is BCNF and what is the candidate key? So here I list some simple assessment questions based on the topic we have discussed today. So also I add the answers for the assessment. So kindly pause the video and take time to solve the questions. This is the reference for the topic. Kindly go through it. Thank you for watching this video till the end.